Hi Year 11. Today I'm going to give you just one example on 3D trig questions. So 3D trig at this point in your syllabus is just 2D trig, but you have to work out what the question is asking you from a 3D picture. So we're going to look at this example where we have a flagpole OP, which is seen from 2 points M and N. And then we're told the angle of elevation at M is 65 degrees, MON is 53 degrees, MNO is 37 degrees, and then the distance from M to N is 100 meters. So all that information is given to you in this diagram. Now, part A asks how far M is from the base of the flagpole. So that means we're looking for this distance that I've highlighted in the picture there. So from M to O. Now, because you haven't actually done any work on non-right angled triangles yet, there must be a right angle in here somewhere. So what we're going to do is look at this triangle that's on the ground. And we have two angles there, so we can work out what the other angle is. So the two angles are 53 degrees and 37 degrees, which is 90 degrees. So because the angles in a triangle add up to 180 degrees, that means that at M on the ground, we have a right angle. So that means we're just looking at the right angled triangle MNO, because that has all the information we need to find the distance from M to O. So the information we have is that there's a right angle at M, we've got 53 degrees up near O, and 37 degrees at N. We know that this distance here is 100 meters, and we're trying to find the distance from M to O. So we can pretty clearly see that the trig ratio we're using is going to be tan, because we don't have the length of the hypotenuse. You can choose if you want to do tan 37 or tan 53. I think tan 37 is going to be easier because then the x ends up in the numerator. So tan 37, opposite over adjacent. To rearrange this, we're just going to times by 100, and we get 100 tan 37. When you chuck that in your calculator, we get 75.355400501 meters. I've written out the whole screen so that when I then round it to the nearest meter, I know that even if I get the rounding step wrong because I'm in a rush, I'm not going to lose marks because I've shown that it was a rounding error, not a calculation error. Okay, that's part A. Part B, we want the height of the flagpole correct to 1 decimal place. So we'll have another look at our diagram. Now we want the distance from O to P. This time we're going to be using this triangle. So MOP. We could also use NPO, the triangle at the front, if we had more information. But because we need an angle and a side, we're going to use the angle of elevation at M and the distance that we just found from M to O. So let's draw that in 2D. We've got M, P, and O. We know that this is a right angle because the flagpole is perpendicular to the ground. This angle at M is 65 degrees from the question, and we just found that from M to O is 75 meters, and we can use our rounded answer there. So the height of the flagpole is OP. We can see again that this is going to be tan. So tan 65 is equal to x over 75. We rearrange that in the same way as we did for part A. 75 tan 65, which gives us 160.838019 meters, 1 decimal place, 160.8 meters. So you can see it's just basic trig, but the diagrams are going to be slightly more complicated, and you just have to work out which 2D triangle you're working with within that 3D example. So, questions that you're doing are from 6C, questions 1, 2, 7, 8, 9. And once you've finished those, make sure that you mark them and then upload them to the class notebook so that I can see that you've completed your work. And remember, you can email me any questions or upload them to the section that says questions I need help with. Have fun!